Okay, so I just wanted to show you a little shortcut with the variables, and we can use this throughout the rest of chapter 10 when we have to simplify. So real quick, if we just look at number 1 on the worksheet, make sure you have the worksheet out in front of you. Number 1 has just variables in it. And so we have n to the 4th, p to the 7th. So yesterday we would have broke them up and said, okay, well, n to the 4th is even. That's how we know it's perfect. So we're going to leave that one alone. And then we would take the time to say p to the 7th is odd. So the biggest even that I can take out of it that's perfect is p to the 6th. And then there's always one left over, right? Well, that's kind of the definition of an odd number. It's just one more from the even, right? So then when we go to simplify this, I would say that I need to make a 4, but I got to multiply two numbers together. It's really add two numbers when we're dealing with an exponent. So that's n squared. And then p to the 6th would become p to the 3rd. And then this leftover p. Okay, well, what you're going to notice every single time is that had I just started off, so look at what we got over here in the very beginning, I can simplify this a little bit for you guys. So square root just means that there's a 2 here. We can't see it, but that's what that means. Even means 2 goes into it evenly. And actually, if you actually just take a 2 and put a 2 there and do the division in your head, how many times does 2, whoops, hold on a second. How many times does 2 go into 4? The answer is twice, right? With no remainder. And so the reason there's no remainder, there's no n inside here. Right? It goes into it evenly. And then how many times does 2 go into 7? 2 goes into 7 3 times, right? Evenly, with 1 remaining. So if you kind of break that down, I know it's kind of hard to do that kind of mental math, but there'll always be a remainder with the odds. So as long as you say how many times does 2 go into 7, it goes into it 3 whole times. So what I'm doing with that p-value is really we're doing division, right? We're saying how many times does 3 go into 7? Twice. So that's, I'm sorry, how many times does 2 go into 7? My bad. And that would be 3 times. And that's your exponent on the outside. You're doing a little bit of division. 2 times 3 makes up for the 6 that was here. And we have 1 remaining, which is right here. So rather than having to show all of this work, with variables, we can kind of use a little division trick. So let's go on and let's look at number 3 real quick. So number 3, I would just like to do the division completely. So x to the 6th, again, I still know it's perfect. So yesterday's whole lesson was about understanding if they're perfect or not. This one's perfect. That means there's going to be nothing left over inside. This one is odd. There's going to be an odd left over. There's going to be 1 left over inside. So what I'm going to do for my shortcut today, for my variables, I'm going to put a 2 here just so my brain can see it. Okay? And I can have my outside and I can have my inside. Now, numbers we're going to do the same way. We're not going to do any shortcut with numbers. We're always going to break up numbers the way we've always broken up numbers. I don't have to break up this whole thing like I did on number 1. How many times does 2 go into 6? 3 times with no remainder. So I'm not going to put anything remaining underneath the radical. How many times does 2 go into 9? 2 goes into 9 4 whole times. That makes 8 of the y's. 8 out of the 9 y's with 1 remaining inside. And there you have it, guys. We don't have to show all that work for our variables. So we went through it yesterday. You saw how it was to break them all apart. Let's try one more here. I'm just going to get another page. Let's go one more this way. So I'd like to try one with numbers. If we just want to do number 5 really quick together. So for number 5, we got the square root of 20, x to the 9th, y to the 8th, and then a z. So yesterday we broke up all of them into perfect and non-perfects. The only thing that we have to break apart now is just the number like we did 2 days ago. So we figure out the perfect and the non-perfect, which is 4 and 5. That makes 20, square root of 4, square root of 5. And then I'm just going to keep all of the variables together, and I'll deal with them with my little division shortcut. We're still going to have a line. We're still going to have a radical because not all of this is pretty and perfect. And then we just go through and we say this all the way down the line, right? So square root of 4 becomes a perfect 2 on the outside. The square root of 5 stays ugly inside, imperfect. And then put a little 2 here, and the rest of our inside and outsides are going to be dividing by 2. How many times does 2 go into x to the 9th? Well, I notice that x to the 9th is odd, so I will have an x left over. 2 goes into x to the 9th 4 times, right? 4 times 2 is 8, with 1 left over x remaining. How many times does 2 go into 8? 4 times evenly, so there won't be any remaining y's underneath. And how many times does 2 divide into 1? It doesn't fit. So this leftover z has to stay inside. So give it a shot. I mean, you're always more than welcome to show all the work. You can go ahead and break that up. I would never tell you you couldn't. But I think today it might be helpful to just try to not have to do this, what we did yesterday, and try the shortcut version. It's a lot quicker, and I think you'll see better results that way. We're not doing any shortcut with the numbers. The number part is still the same. The only difference is I didn't have to break this whole thing up. I just left it and did division. So good luck.